But then we realized that actually there's another way of doing things, which is instead of tapping off the input into Bitcoin, okay, we can tap the output of Bitcoin, okay? And so merge mining has become, I would say, merge staking.
So, hi, I'm Shane. I'm joined by David Shea today, who's a Stanford professor and also the co-founder of Babylon. My background is that I actually did my PhD at Stanford in electrical engineering, the same department as David. It turns out he was actually my interviewer for the PhD program. I don't know if you remember that.
Oh, amazing. Actually, wow, this is a shocking development here in this dialogue.
And now we're here discussing Babylon. Some other parts about my background. I for the last 4 years have done crypto MEV trading across various blockchains, starting with Ethereum, and then Binance Smart Chain, all the way now to Solana. And I'm also a research partner at Hack VC and run these whiteboard sessions, which we call the Gigabrain Sessions. So David, I'll let you give a little introduction.
Yeah, so Shane, so nice meeting you here again. Um, yeah, so I have a research lab at Stanford on focusing on blockchain consensus protocols. We have done contributions to, for example, the Ethereum proof of stake protocol when they had the merge. In the past few years, we got interested in this problem of sharing security of the Bitcoin chain and use it to benefit the rest of the ecosystem. And as we started this project about 3 years ago, when Bitcoin was twice the price of Ethereum, twice the FTV of Ethereum. Now, 3.5 years later, Bitcoin is 7 times the FTV of Ethereum, and the security remains the strongest ever.
Mm-hmm. Great, thank you. So let's just get started, like at kind of a high level. If you had to give a high level overview of what Babylon does, what would that be?
Yeah, so the technical problem we're trying to solve is the problem of security sharing from Bitcoin. In fact, this problem has a very, very long history. Nakamoto himself in 2010 or 21 time frame, when he was still working on Bitcoin, he proposed this problem of security sharing, how to build new blockchains by leveraging off the security of Bitcoin itself so that we don't have to bootstrap the security of every new blockchain that we build. So he came up with a solution called merge mining. And this is a beautiful solution he came up with. And in some sense, what we're doing in Babylon is merge staking, because now we have moved from a proof of work world purely to a world where proof of stake is very significant. And so that is essentially what we're building here at Babylon.
So basically turning or allowing Bitcoin to be proof of stake instead of proof of work.
Yeah, so if I can start drawing a few pictures. So you can think of Bitcoin, okay? Bitcoin is like an engine, and there's energy going into Bitcoin. It's proof of work. And the output is the asset, BTC, okay? So energy comes in, Bitcoin convert that energy into a very secure asset worth today, I don't know, 1.6, $1.7 trillion. Now, what Nakamoto says is the following, okay? Nakamoto says, okay, suppose you want to build a new blockchain. In fact, one of the first new blockchain that he was contemplating, or people were contemplating, is called, I think, Namecoin, if I remember correctly. It's like a domain server for Bitcoin. And then people were saying, okay, why don't we build this new application called Namecoin or domain server right on Bitcoin itself? Is like, no. That's polluting Bitcoin. Bitcoin is very limited block space. Don't just put your random applications on my blockchain. focus on Bitcoin as just a pure payment system, but build new applications by launching a new blockchain. And then people say, hey, well, okay, good, I can launch a new blockchain, but where do I get all this mining power? Well, how do I convince miners to actually go and mine my chain? Because my chain is a no-name chain. It's a name coin, but initially there's no name. And so Nakamoto said, hey, why don't we do this? I have a way of using the cryptography of proof of work to actually do this for you. Okay. Which is I can use exactly the same miners that were securing Bitcoin and add a piece of software to them so they can reuse the computational power. So whatever they were doing, you don't have to do anything extra energy, but you can reuse it to secure a new coin. In this example, Namecoin. So this is the concept of merge mining that Nakamoto came up with in 201011 time frame, even maybe just before he left the field altogether. It's a beautiful idea. It requires a pretty deep understanding of how proof of work works, but it actually works. And this is so now in this example, Namecoin has become another proof of work chain, okay? Another proof of work chain. Now, but the problem now is that nowadays, when people launch a new chain, typically it's not a proof of work chain, right? Very few people launch new proof of work chain anymore. Instead, they would launch a proof of stake chain, okay? This is the way to launch new chains, proof of stake chains. For example, the Cosmos ecosystems, sorry?
Require just a massive amount of compute to run the chain.
That's right. It doesn't require massive amount of infrastructure, I should say, right? Because it's not just a mining power. You need to go and recruit miners, the hardware, energy sources, a whole lot of things to launch a new proof of work chain. And so now, suppose I want to launch a proof of stake chain, okay? Proof of stake chain now. Instead of Namecoin, I have a new proof of stake chain. Example, I don't know, Barratt chain, Story protocol, they're all proof of stake chain. In fact, they're all based on the Cosmos SDK stack. Okay, so suppose you want to launch a new chain this way. Well, chains like Barratt chain and Story, when they launched, they had to go and recruit a lot of validators and convince them to buy into the asset and people to delegate and so forth to secure chain. However, now, so here's the idea. Instead of using proof of work merge mining, which we cannot now use because it's no longer proof of work chain, it's a proof of stake chain, our idea is actually, on hindsight, pretty simple, although it took us a few years to figure out. Because honestly, when we started working on Babylon project, we were just using the proof of work merge mining concept to do security sharing. But then we realized that actually there's another way of doing things, which is instead of tapping off the input into Bitcoin, okay, we can tap the output of Bitcoin, okay? And so merge mining has become, I would say, merge staking.
Is it worth explaining at a high level what merge mining is, or is it kind of too complicated?
Okay. So merge mining at a very high level works like this. The reason why I did not go into it is because it's not that relevant to what we do in Babylon anymore. But at a high level, what merge mining is this, right? In mining proof of work, you are basically using a lot of computational power to solve a puzzle. Okay? Now, in Bitcoin, these puzzles are super hard. That's why so much energy is spent in solving the puzzle. However, during the process of solving the puzzle, actually, you have also solved many easier puzzles, okay? Easier puzzles. But in Bitcoin, those easier puzzles you don't get any credit, okay? Merge mining basically gives you credit as you solve easier puzzle. And the credit is essentially contributing towards generating blocks in the other blockchain. So that's roughly how merge mining works.
Okay, yeah, I think that makes sense.
So in other words, energy is not wasted because when you get no credit on Bitcoin, you can still get some credit on the other chains. And these other chains, yeah.
overhead, right? So if you were doing that for 1,000 chains, it kind of slows down the original mining to some extent.
Actually, it doesn't slow down the mining because the chance of getting a block is still exactly the same as you were not merge mining. And so, um, however, merge mining has a various technical difficulty. Okay, so it turns out that in merge mining, you have a problem because there is a problem of, so to speak, nothing at stake. Okay, so in security, it's very important that you have something at stake when you're securing a blockchain. So in proof of work, there's something at stake is your hardware, is your energy. You're spending all this money buying this hardware. All of this is just to secure this chain. And if the chain has a problem, then all this investment you made is like all went into the ocean. Okay. Merge mining has a problem because in some sense, um, you can actually go and attack the other chain while doing perfectly good business on Bitcoin. Okay. So it has this property, what we call nothing at stake. And so that's one reason why merge mining never really took off. There are a few projects building on merge mining. The most famous is Dogecoin, which is merge mining on Litecoin. But and Dogecoin, as you know, is basically a meme coin. Um, Other than that example, there's no really big prominent example of when merge mining is successful. Okay. And I think one of the problem from a security point of view is nothing at stake on the other chain.
So I guess that leads us perfectly into merge staking.
Yeah. So merge staking has something at stake. Okay. Has something at stake. And that's why it's called merge staking. Uh, and we invented in 2023. Okay. 2023. So it took us about 12 years going from merge mining to merge staking. And it really is the merge staking is really a emergence of proof of stake as a key technology that sort of explains why merge mining becomes interesting, right? Because if there's no proof of stake, there's also no need to do merge staking. So that's it. We're basically using Bitcoin as a collateral,
Mm-hmm.
okay? The asset to secure proof of stake chain. So this concept took us actually quite a few years to figure out because the Bitcoin everyone knows is a proof of work chain, right? Everyone knows proof of work. So if you plug Bitcoin together with a proof of stake chain, it seems like it's a mismatch, total mismatch. One is proof of work, one is proof of stake. Yeah, totally. Yeah, block time is an issue, total mismatch. But then one day we came to this observation, which on hindsight is like a stupidly simple observation, but took us many while, is that hey, although Bitcoin is a proof of work chain, the output, the asset, is still an asset. It's still it's a crypto asset. It's a digital asset. It doesn't matter really how the security of Bitcoin comes about, whether it's proof of work, proof of stake, proof of space, whatever it is. It is the asset that is valuable, and therefore we can use this asset to provide collateral to secure proof of stake chain. And so the matching of Bitcoin and proof of stake chain comes from the fact that one, proof of stake is secure by digital asset, and two, Bitcoin is a digital asset, and three, proof of stake chain does not need to be secure by its native asset. In other words, you don't really need to issue a native asset to secure the state chain. So, all right. So three things, right, of the emergence of this concept of merge staking. One, emergence of proof of stake. Bitcoin is secure by proof of work, but it is a digital asset, like every other digital asset. And three is proof of stake chains can be secure by any digital asset.
Meaning essentially just something that you can put up that can be taken away. Is that the basic concept?
That's right. That's right. So this ties into the story of Vitalik. Okay, so Vitalik comes into the story now. When people start thinking about proof of stake chain, okay, they've always been thinking, oh, okay, we replace work by stake, okay, and people say, oh, okay, as long as 1/3 of the people, 1/3 of the stake, okay, is not malicious, then my chain is secure. Well, however, this is an academic statement because how do you make the assumption that 1/3 is not malicious? How do you, right? You cannot really just trust people from being honest because, after all, there's a lot of money involved in these blockchains, right? So you cannot just trust people, hey, just keep honest and you'll be fine. So Vitalik advocated this concept of accountability, okay? That proof of stake chain really means that if you are not doing the right thing, you should be punished. Your collateral, your security, your stake can be taken away. So Vitalik advocated. Am I spelling Vitalik correctly? No, Vitalik. Okay, Vitalik made the observation of honesty assumption.
And this is regarding Ethereum, which they started as proof of work, right? And then switched to proof of stake.
That's right. So many people thought that Ethereum was moving from proof of work to proof of stake, mainly or solely because of energy environmental reasons. Okay. But actually, another main reason, perhaps environmental reasons also one of them, but another main reason, perhaps even more important for Vitalik and Ethereum Foundation folks, was that proof of work is not really accountable. So in other words, if you do bad things in proof of work, okay, you can't really go and burn the guy's hardware. You cannot go and burn the guy's hardware. But for asset, you can actually burn the asset. You can burn the asset because the asset is literally recorded on the chain itself. And so that is his main observation. So Vitalik have made this observation that, just honesty assumption, assuming 2/3 is honest, is just not good enough. Okay? We need to have accountability or slashability. In other words, bad actors needs to be slashed so that they are threatened to do the right thing.
Yeah.
You cannot just trust people's altruistic beliefs when you're securing a blockchain which is 230 billion worth.
Which slashing will never happen in Bitcoin itself, obviously. But basically, your view is that you can put an appendage on top of it, which allows Bitcoin to become slashable. Is that
okay? The story, no, at this point, I'm just explaining the Ethereum story, right, really. Okay? This is the Ethereum proof of work to proof of stake migration story, okay? So what Ethereum did was they abandoned proof of work to move to proof of stake in order to enjoy the slashability security. Okay? Now, moving from proof of work to proof of stake is a huge, huge move. Okay? Vitalik took I think 7 years to make this move. 6 or 7 years. Because he started thinking about this move in 2015. Okay? So however, the observation here that slashability is very important as a security property of proof of stake chain leads us to, in some sense, point number 3. Okay? So point number 3 is what, right? If you look at all the early proof of stake chain, in fact, all the existing proof of stake chain, they're almost all secured by the native asset. Okay? Now, however, if you think about security as slashability, as collateral, then it doesn't really have to be the native asset. It could be any asset. Okay? So slashability or collateral implies security or stake, okay, stake as collateral. This implies any asset can provide security to a proof of stake chain. Okay.
And
So
Vitalik
that's
about this, or
so Vitalik is up to here.
yeah,
So this, okay, going from this step, okay, is now a observation by several teams, including Eigenlayer, Shriram Kannan, Sunny Algoa, Mesh Security, Eigenlayer restaking. All these concepts are basically around this observation, okay, that if stake is a collateral, then it doesn't really have to be a native asset that provides the security. Another blockchain can provide security to another blockchain. Okay. So that's the picture. Okay. So the picture is example, right? So in Cosmos, there's a chain called Osmosis. Okay. There's also another chain called the Cosmos Hub. Okay. Now, what Sunny was advocating was that Osmosis can actually provide security to Cosmos Hub, and maybe even Cosmos Hub can provide security to Osmosis.
yep,
So, and the reason is precisely because the observation that stake is just a collateral. And so if you have a collateral is truly slashable, then you're providing security. It doesn't have to be the native asset. So this is mesh security.
yeah. The view is that all Cosmos chains would kind of secure each other, making the sum, or the whole greater than the sum.
Stronger. That's right. That's right. And so this idea came in 2023 Cosmoverse. Okay. And there's also this concept of restaking, which is a very similar concept. Okay. So these ideas all emerge in 2023. Okay. All right. Now I went to Cosmoverse. I'm a good friend of Shriram, so I'm very familiar with all these ideas. So then I had the idea that, hey, you know what? Actually, well, since security can be any asset, clearly it is the biggest asset that has the biggest potential to provide a lot of security. Right? And that's kind of obvious on hindsight. But everything on hindsight is obvious, by the way. Okay. But all these are new concepts. They're emerging, and now you can see that we bring together quite a lot of different ideas together.
And people
So
were avoiding Bitcoin because it was seemingly harder to use for security because it didn't have smart contracts, for example.
no. I don't think so. I don't think people are stuck because there's no smart contract. People are just stuck because mentally, Bitcoin is proof of work.
Mhm.
So nobody ever puts Bitcoin into the story. Look at the story, right? Osmosis, Cosmos Hub, Ethereum, AVS, they're all proof of stake systems.
Yeah.
The psychological gap is that Bitcoin, nobody thinks of that as part of the proof of stake ecosystem, right? So the picture of crypto is basically this. You have Bitcoin, and then you have proof of stake. Okay? Bitcoin is actually more than half, so it's a bit bigger. And so this is how people think about crypto. And so all this restaking, mesh security is all happening inside here. Okay? But then once you sort of start thinking about the problem, And we were thinking very hard on how to share secure Bitcoin. Then it became like a very natural problem to ask, okay? Which is, how can you build a system where you can use Bitcoin as a collateral to secure a proof of stake chain? Okay? So that is the system. So I'm trying to emphasize, Shane, one thing, right, is research. Asking the right question is like half the battle. And I'm trying to say that the challenge, the reason why people took a while to figure this thing out is not so much because of the problem is difficult to solve. It's just no one has been asked the question.
Yeah. How do we use Bitcoin
As a collateral to provide security for proof of stake chain. And this one statement kind of unifies Bitcoin and proof of stake world.
Mm-hmm.
Okay. Now, once you start asking the question, then the difficulty of the problem arises. Okay. Because now you realize that all these mesh security eigenlayer, they're all built using smart contract. In fact, these are essentially entirely smart contract based protocol. Okay. Because you have to do slashing, you have to go and verify some kind of violations of protocol, etc. All these require smart contract. Okay. But then we realized that Bitcoin has no smart contract, no native smart contract. They have a language called the Bitcoin scripting language, but it's very limited language. And so it becomes like, okay, maybe this is an impossible pipe dream. Okay. Now, but then one day we come up with an observation, which is the following. Okay. Which is proof of stake chains. The key protocol violation is called double spend. Okay. If you look at Nakamoto's white paper, in fact, he said, hey, you know what? The whole problem we're trying to solve using Bitcoin is the double spend problem. Because he said cryptography basically says that you can't forge a signature. So you cannot pretend to be someone else. You cannot take someone's Bitcoin and pretend to be yours. Okay. However, cryptography cannot prevent you, a user, to pay the same Bitcoin to two people at the same time and try to buy two things instead of one thing. Because if people can get away with doing that, then the currency trust will collapse.
Yeah.
Okay. So he said the whole project of Bitcoin, the protocol, is to solve the double spend problem. And so when we start focusing on this particular protocol violation, although seemingly very narrow, but very important, then we were able to overcome this lack of smart contract. And we were able to use cryptography itself to emulate a smart contract. So that's basically what we solved. That's basically how we solved this problem of Bitcoin staking. So this is the problem. Now we talk about the protocol. This is now the Bitcoin staking protocol.
So let's break it down. I guess, what is the smart contract that you're trying to emulate?
Yeah. Okay. So what are we trying to emulate here, right? Now, before I do that, I should say that there is actually another solution, which in fact was proposed to me by Sunny himself. When I discussed with him this problem, he said, "Yeah, actually, no, we can solve this problem." How? So Sunny's proposal was this: you have Bitcoin, and then you bridge it to a proof of stake chain, and then you stake the WBTC, wrap BTC, I don't mean the specific WBTC, I mean the wrap BTC. Okay? On pure proof of stake chain. That was his proposal. And then he cautioned me. He said, but there's a problem with this proposal I am aware of, which is building a secure bridge is very difficult. Okay.
It reduces to as hard of a problem as the original.
So it kind of reduces to a problem, which is, again, another difficult problem. Okay. And so that was his proposal. And after discussing with him, I remember that was ETH Denver, I think, ETH Denver 2023. I went back home, started thinking about it. And then we realized one thing is that actually this idea of bridging the asset to proof of stake chain is actually very different from all these other solutions, mass security or Ethereum restaking. Because in these solutions, the slashing of the asset is always in the native chain. There's no bridging in any of these solutions. Okay? So no bridging. So I said, well, if these guys can do it without bridging, then we should be able to do it without bridging either. So, which says that in some sense, the bridging problem is actually even a more difficult problem than the one we need to solve.
Yeah.
Because if you think about it, bridging gives you a lot of flexibility of the use of the wrap asset. You can do many things with it. But for us, we don't need to do many things. We just need to form a collateral so that it can be slashed if bad things happen to the validator. Okay?
Yep.
And so our solution is basically the following. Okay? All right. So now we go to the solution. So we realize that Bitcoin, okay, can be done. There are only two things basically to do with Bitcoin, supported by the opcodes, okay? One is you can lock Bitcoin. Okay, so you can lock the Bitcoin for a certain duration of time. So there's an OP code, opcode, called OPCLTV, okay? OPCLTV, okay? Which allows you to lock for a certain duration. Two, you can spend the Bitcoin via signatures, okay? So Bitcoin can say that, okay, if you can sign the signature correspond to the public key in the spending condition of Bitcoin, then you can spend it, okay? Now from these two things, we want to build a staking contract, okay? But there are only two things. In fact, Bitcoin really only has these two things, not too many things, okay? So one is very good because any staking contract, you have to lock the asset. You cannot allow it to be free floating. Otherwise, it's not staking. Okay? So one is very good.
It's really hard to design some sort of signature system that locks for a certain amount of time. So it's good that it's built in.
Yes, it's good that it's built in. Indeed, it's good to build in. But two, we want to achieve. So here we have locking. So which is achieved by one, very good. But the second one is slashing, right? As I mentioned to you. Double spend has been slashed. Okay? Now, but all we can do is to spend the Bitcoin by signing. But slashing seems like a very complicated condition that you need to verify on the proof of stake chain. All right? So the challenge here is to build the gap between the condition of violation to the spending of the Bitcoin.
Which is specifically the double spend condition that you're considering here?
Yes.
So if someone double spends and you have proof of that, you basically want to somehow slash the Bitcoin.
Right. I want to spend the Bitcoin.
Spend the Bitcoin, send it to zero address or something.
Yeah, it's called burn address. Yeah, you send it to a burn address. In fact, you can, okay? So now what we figure out is that we can reduce the double spend event to a concept called double sign. Okay? That means that we can show that by designing a protocol carefully, the proof of stake protocol, whenever the validator double spend, then it can be reduced to always the validator signing 2 blocks on the same height. Okay? So just give you a figure here. So you're a blockchain. Okay, you're a blockchain. A nice blockchain keeps on going linearly. There's a proof of stake chain. Okay, but a fork happens this way. So there's a double spend. Okay, if you have a double spend, that means a validator has double sign on these 2 blocks. Okay, all right. So and then we figure out that actually cryptographers has this concept called a one-time signature. Okay. So this one-time signature is a very strange thing. It basically says that it is like a normal signature if you sign it once. But if you sign it twice, you use the same key to sign it twice, then the private key automatically get leaked by anyone who observed the 2 signatures. Okay? So now we're putting 1 + 1 = 2.
Yeah.
We want to punish for double sign. We have this technology called one-time signature, and then we put it together, and we got what we want. Because the double sign using one-time signature will imply private key leak. And that will imply the Bitcoin staked can be spent if the private key is what controls the spending. Okay? So we simply uses the public key, which matches to that private key, as a condition for the spending condition of that staked Bitcoin. And so if the validator does a bad thing, then this private key gets leaked and this Bitcoin gets slashed.
Okay, but spent generally can be sent anywhere, or how do you?
Yes. So we have to do some protocol design to make sure that it's spent to a burn address. So that's very important, because otherwise, if people can, if a validator, for example, because the validator has the private key, right?
Yeah.
So if the validator says that, oh, I can actually go and spend this money and send it to my own wallet, okay? Then that's not a good incentive system, because then the validator can rug pull the staker.
Yeah.
But if the validator said, well, the best I can do is to send it to the burn address, then there's no incentive for the validator to rug pull the staker, because the staker is actually the validator's customer.
And so then how does it work with locking? Because at the moment that I'm assuming the Bitcoin is locked,
Yeah.
and the moment that this double sign happens, you want to immediately slash them, right?
Yeah. So exactly. So the locking, okay? The locking says that the Bitcoin will be locked until a certain time. But if the slashing happens before that, slashing will take precedent, and slashing will immediately happen. So it's an or. Logically speaking, it's an or. Bitcoin gets spent if you wait for 15 months or slashing happens, whichever comes first.
Okay, and the Bitcoin is able to support that with just those two opcodes?
Yes. So this is very easy. You can specify spending conditions, which is the or. Yeah. So it supports basic logic, right? Like or and so forth. Yeah.
Okay. Yeah. And so, but this is so can you scroll up a little bit? Um, so the validators have to basically use a specific type of signature on the POS chain to sign the blocks. This double
Correct.
one-time signature. So which is slightly different than what's often used, right?
Yeah. So that's right. So our design. So actually, our design. What happened? Oh, there's. Our design is actually modular. Okay. The modular design is the following. Okay. You already have a consensus protocol running.
Mm-hmm.
For example, in Cosmos, it will be Tendermint. In Ethereum, it will be the Ethereum proof of stake protocol. In Avalanche, it will be Avalanche has its own protocol. Every blockchain has their own protocol, right? You have Sway, you have protocol. Now, everyone has their own protocol. Nobody wants to go and change the protocol, okay? Just because they want to get Bitcoin staking. All right, everyone has their own protocol. So our design is very modular in the sense that we put on top of the existing consensus protocol a BTC finality gadget. Okay. So this again borrowing a concept invented by the great Vitalik. Vitalik in 2018 or 19 timeframe wrote a paper called Gaspar the Friendly Ghost. Okay. That was a Fnatic gadget that he came up with. The idea of Fnatic gadget was to add further security property on top of Ethereum. Okay. This was a precursor to Ethereum proof of stake. So we took this concept and apply it to the Bitcoin staking protocol and say that basically Bitcoin staking protocol is applying a Fnatic gadget on top of any existing consensus protocol by adding one more layer of signatures, these one-time signatures, to give security, Bitcoin level security to an existing consensus protocol. So then that means that anyone can launch a blockchain using existing consensus protocol like a Cosmos stack, and then they can add our Fnatic gadget on top of that to get this Bitcoin staking security.
So like there will be Ethereum. So this could work on Ethereum today. There's Ethereum already staked. It's running its own consensus protocol. And on top of each block, you do a separate one-time signature and run this.
Yes, correct. Now, to be honest, Ethereum main chain has not come and talked to us and said, "Hey, can we get some Bitcoin security, guys?" Okay, just to be honest. However, we do have projects that are building on EVM chains. Okay, EVM chains, which is essentially adopting Ethereum, EVM, and consensus protocol, and working with us on Bitcoin, getting Bitcoin security. So that is happening already.
Great. So I think we've kind of wrapped up this section. Should we talk about Bitcoin timestamping? How is that related to this?
Okay. Yeah, sure. Now, okay. So if we want to talk about timestamping, okay, then we have to talk about an intermediate step in our project. Because when I remember, I said that our project started with merge mining, which was a Nakamoto 2021 concept, okay, and then we moved to Bitcoin staking or merge staking, which is the concept we came up with in 2023, okay. But actually, in between, there was another protocol that we came up with that I skipped in the earlier part of the story. And since now you ask, I will now show you this part of the story. Okay. In between, there was a protocol that takes the security not from the input, not from the output, the asset, but from the blockchain itself. Okay? From the blockchain itself. And this is what we call a Bitcoin timestamping. Okay? So the idea here is that you want to use the blockchain as a way of timestamping the ordering of events in a proof of stake chain.
Mm-hmm.
And so that if you have a fork on the proof of stake chain, then you can just use the timestamp, which is the earlier timestamp on Bitcoin, to help you to not get confused and everyone remains in consensus as to what is the correct canonical proof of stake chain is.
So that's
Okay?
protecting more against reordering than the double spend necessarily.
Yeah, that is also protecting double spend. Okay. But now the reason why we moved to Bitcoin staking is that this timestamping is kind of only useful in a slow time scale because the fact that it's directly timestamped on Bitcoin means that it sort of inherits the slowness of Bitcoin.
Okay, so as mentioned earlier, I talked about block times, but the Bitcoin, what you call merge staking, I guess, gets around this, gets around the issue
Yes.
of,
Yes, merge staking gets around that because merge staking is just putting more stake on proof of stake. It doesn't touch the Bitcoin chain itself.
yeah. So the time
So
stamp is kind of an intermediate idea
that's
that
right.
a lot of research on, and that was kind of an intermediate step to end up at the final kind of iteration. Is that what you...
Yeah, correct. It turns out that the timestamping protocol became a support to the merge staking protocol. So there's a long story, but the timestamping is actually important for merge staking as well. But I think that is kind of like you don't since you mentioned earlier you don't want to go to a PhD level discussion. So I think I'll save that to another time. But the story is, yeah, we go from the input to the chain to the output, and that was the evolution of our thought, and that was basically the evolution of Babylon, the project.
It's a great summary. So I guess I have another question if you want to scroll back to the bottom. In EigenLayer, there's this idea that you can simultaneously secure multiple chains at once. Does the same idea exist in Babylon? And if so, how?
Yeah, yes, it does. So why? Let's think. All right. So you can think of it this way. Maybe I draw a picture now. You have this one Bitcoin, okay? All right. So in the lingo of Bitcoin, this is called UTXO, unspent transaction output. Okay, one Bitcoin. Now, how you should envision the coding or the staking contract or any contract on Bitcoin is that you specify spending condition. In other words, you specify conditions at which that UTXO can be spent. Okay. So as I mentioned, one of the spending condition was a locking, lock for 15 months, for example. Another spending condition is slashing, right? Now, suppose you want to use this Bitcoin to secure two chains, okay? Then you can have one spending condition is slashing on chain one spending condition is slashing on chain two. More precisely, actually, is slashing on a validator on chain one and slashing on another validator on chain two.
Mm-hmm.
So if either of the slashing event happens, then the UTXO gets spent, or at least a fraction of the UTXO.
Or basically of all of these.
Yeah, so it's an or of both of these. So this is how this concept, which you mentioned earlier, which we called multi-staking, can be achieved. That is, you can use the same asset to secure multiple blockchains.
Mm-hmm. And then what is the incentive of someone to secure multiple blockchains? Are they given rewards, or how does that work? Are the rewards in Bitcoin or the native asset?
So it depends on the chain. Uh, there are some chains which will give you reward on a native asset. There's some chains that would give you a reward on the transaction fees. For example, so the reward structure varies chain to chain.
Okay.
But the point is that the reason why people want to do multi-staking, because now they can get multiple stream of rewards from different chains.
To increase the yield, yeah.
Yes.
But that obviously increases the risk. So are you guys
Yeah.
thinking about the risk in that setting, or?
Yeah. So this is entirely a risk that is taken by the staker.
Yeah.
So the protocol is agnostic, right? The protocol is like, okay, we give you this ability to sorry, to express your staking. Now you can decide to just stick on one chain. You can decide to stick on two chains. And that's the risk reward trade off that each individual staker can take. It's not a system wide trade off.
Yeah. So are there any other topics you would like to cover?
No, this is quite a topic already, I mean, we started off with Nakamoto in 2010, and then we end up in 2025.
Here we are. All right, so we'll conclude there. David, do you have any kind of final thoughts about like the future of Babylon, or where you think you guys will end up, in say 2027, or just anything to finish off with?
Yeah, the thing is that one part of this journey of Babylon is really to discover that there are so many interesting things you can do with Bitcoin, in particularly to do it in a trust minimizing fashion. And so our North Star has always been building protocols that is trust minimizing and leverage off and utilize Bitcoin in creative ways. And I think staking is only one step in our journey. We are always trying to innovate on new protocols, new ways of using Bitcoin natively.
It's a great North Star. So thank you, David, so much for joining us for the Hack VC Gigabrain session.
Yeah, thank you so much, Shane. Yeah.